Good morning, everybody. My name's Seb. This session is called So Long and Thanks for All the Tests. And I wonder how many of you are familiar with the inspiration for this title. So could I just have a quick show of hands? Who's read any of the Hitchhiker's Guide to the Galaxy books? Some, okay. It's always worth asking because they're quite pervasive through the development community, but I'm not sure if they exist in Polish. Have they been translated? Yeah. Okay, so this is one of the books. The title of one of the books in this series is called So Long, Thanks for All the Fish. And it refers to a point in time just before the Earth gets destroyed when the dolphins decide that it's time to leave. And their message, their last communication with humankind, is misinterpreted as a jump through a hoop, when in fact what they're trying to say is so long and thanks for all the fish. And the point here is that they didn't need us to give them fish. Right? They are dolphins. That's what they do. They swim in the seas and they eat fish. They can catch them themselves perfectly happily. And what I want to ask you is, do our applications need tests? So I'd like to think about that just for a second, because there's a wealth of information out there about unit testing, integration testing, systems testing, manual testing. And sometimes it's worth just stopping and looking at what we do and saying to ourselves, do we need to do this? Why do we need to do this? What are we trying to achieve? Okay, we've thought about that. I'm not going to ask you to tell me what your thoughts were just at this moment in time. What I want to do is give you a slight warning. As we go through this session, there'll be a number of slides, and on some of those slides are pictures of books that I think are important. So if you're in the software community, you've probably already got a reading list. You've probably got books that you've bought that you've never read. You possibly have more books that you've never read in your collection than books that you have read, if you're anything like me. So I'm afraid I'm going to try and add to that list. All of the books that I'm going to talk about, I think, are extremely valuable for people working in software development. Ooh, one too far. So here's our first one. Jerry Weinberg, I hope, is no stranger to most of you. He's one of the better-known consultants in the software field. He's done some really, really exciting and interesting work. And this is possibly one of his lesser-known books. It's got I think, a very funny title, Perfect Software and Other Illusions About Testing. And it's a great book that gives you a feel for how testing could work and why you would do it. But the reason I've got it here is because I think that this is a really important quote. Why are we testing? Testing is a process of gathering information about software with the intent that the information could be used for some purpose. Now, an awful lot of testing that I see isn't used for any purpose whatsoever. It's one of those things that people go through in organizations that they don't expect to deliver any value. So let me ask you, have any of you got continuous integration running in your companies? Quite a few. What happens when it goes red? Sorry? Yeah, red is the new green. Thanks, Lewis. That's a good one. So the idea about continuous integration is that we get quick feedback about what we've just done so that we can fix it. So if you look at any of the literature on continuous integration, the bottom line is that your highest priority is to fix a broken build. And that's so you don't check in on top of it and loads of other good things that go with it. I've been to companies regularly where the continuous integration build is broken, has been broken for quite some time. I was at a bank earlier this year, end of last year. They had one CI build that had been broken for 5 months. And you have to ask yourself, what's the point of having a continuous integration build if you're just going to ignore what it tells you? This is an example of testing that's not being used for any purpose at all. So, time for a little bit of audience participation. What are tests for? There's not a lot of you, and you're distributed over a large auditorium, so you might have to shout. Anyone who would like to give us some ideas about why we would write tests or why we would test? Test specs. Test our specs. Okay. Because Kanban told us. Okay, Scrum Mum, sorry, thank you. Okay. Well, so those weren't any of the ones that I was expecting. Okay, so the first reason that often I get told by developers is to make sure that my code works. And preventing regressions is often the second reason. If you're going to write tests, are there any other things that you might benefit from? Okay, it tells the status of code and development process. One of the ones that I was thinking of was I think that our tests document what the system does, document how the code behaves. So I find the documentation aspect, especially of unit tests and behavioral tests, to be extremely important, especially when you're bringing people onto teams and trying to do maintenance on code bases that have been kicking around for a while. It's difficult to know exactly what the system is supposed to do because quite often the written specifications can be out of date. And another thing that you find typically in the literature, especially if you use the practices such as test-driven development, is that you will find people talking about the tests actually driving out a good design. So if you're talking about unit tests, it's about how would you consume that class? What's the API going to look like? How are you going to interact with that part of the system? And if you're thinking about system or behavioral tests, you're thinking about how are the users going to interact with the system. And it's part of the process of trying to work out whether our design is fit for purpose. So these are, for me anyway, these are the four most common reasons that I hear about why people would want to test a system. And so I'd like to just introduce you to the testing pyramid. Now, is this well known to people? Who's seen this before? Okay, quite a few folk. For those that you haven't, this is basically a pyramid. It's not a pyramid, is it? This is a triangle, but it's called the testing pyramid. And the idea here is that the wider it is, the more effort, the larger the number of tests there are in that area. And the higher up the pyramid you go, the more of the application stack each of the tests will exercise. So down here, you're only exercising small components. Units is what they're often called. And as you go up, you move through larger subsystems towards end-to-end system tests. And then at the top, we have something to remind us that no matter how much unit testing or automated testing we're doing, there's always time, space, and need to do manual and exploratory testing. So to try and make this concrete, I'm going to use an analogy with a car. And so we have down here in the unit test, we're thinking about small components that you can test in isolation. You know, an indicator light, for instance, or an ignition. You could put that on the rack and test it in isolation to make sure it behaves as you expect. Then as you move up the stack, you get assemblies, subcomponents, subsystems, the cooling system, the steering rack. And then when you finally assemble the car, you might put it on a rolling road, and you'll be testing the whole system in a controlled environment. And then finally, before you get to drive your brand new car, you put it out on the test track, you use test dummies to make sure that it behaves according to the requirements actually out in the real world. So this is the pattern that has been recommended. I think it was first documented by Martin Fowler. This is quite often not the distribution of tests that I find when I go in and speak to clients. So there's a whole school of thought that has far more tests that are system tests, that are automated, with hardly any unit tests. There's one anti-pattern which is called the ice cream cone. So instead of being a triangle, it's an inverted triangle, and they call that the ice cream cone anti-pattern. There's another one which I've seen, which is maybe less prevalent, which has very few end-to-end tests, very few unit tests, but quite a lot of integration tests. So this is where, with systems where people find it hard to test the UI, so they don't, and they find it hard to disentangle the rest of their business logic from, say, the network or external components or the database. And at that point, you get large amounts of subsystem tests, hardly any unit tests, and hardly any end-to-end tests. And I've coined that one the beer belly anti-pattern because it sort of sticks out like that. And so what do we want out of our tests? Over the years, I've tried to distill the essence of good testing. And these are the properties that I've come up with. I think one of the first things that a test should be is understandable. So why are we testing? We're testing to make sure things work, to document the system, to make sure that the design is fit for purpose. But when something fails, we need to go back and we need to immediately be able to see why it's failed. What was it that we were expecting the system to do? So if when your CI build fails and you go to your failed test and you look at the test and you've got, I have no idea what this test is for, then you have a real problem. What happens is you either leave the CI build at red, which, as I've said, I've seen happen on numerous occasions, or perhaps you comment out or delete that test because you don't know why it was there. So you have to have tests that are understandable. Maintainable, this is something that we'll get onto a lot later because maintainability is one of the major complaints that people have around test suites, which is that they impede the ability of the software team to change or enhance the software. If you go and make a change to a piece of functionality and suddenly all of your tests break and you spend weeks and weeks making your test suite run again, you're not going to be very keen to add new pieces of functionality. You certainly aren't going to be able to respond to change in the way that we would like. So for instance, I worked at one company and there was a major API change from version 6 to version 7 of the software, and all of our tests broke. And so what we did was we turned them off. I went back to that company 10 years later, and sure enough, they were still turned off. So it's a very, very dangerous thing to do. You need to make your test suites maintainable. Repeatable, that should be completely obvious, right? So if a test passes today, it should pass tomorrow, and it should pass the next day. This is something that we would like to see in all of our tests. They sometimes called flickering tests or flaky tests. And if you find flickering or flaky tests, that's often something that leads to your red status in your continuous integration build. Because what's happened, the integration build is at red, someone comes in and you're all fired up for continuous integration, so you go and try and work out why did that test fail. You bring the test down locally, you run it, it passes. You put it back up onto the CI server, it passes. Tomorrow it's broken again. It only takes that happening 2 or 3 times before you just go, oh yeah, that test sometimes fails. So these are really bad things because they erode the trust in your test base. So tests have got to be repeatable. Necessary? Now this is a really hard one to define. Not all tests are necessary. So I won't fling it up here because it doesn't fit into the context of this talk. But you can sometimes find, especially in teams that use data-driven approaches, vast amounts of tests being run through that one test would have been perfectly sufficient, or at least a set of strategically chosen tests. You don't have to test every method, every subcomponent with every possible set of data inputs. So there's black box testing and white box testing. There are different approaches for analyzing what tests are appropriate. But it's always worth looking at a test and asking yourself, is this test adding any value? Because if it's not adding value, then it is waste. You will have to maintain it in the future. Too much maintenance burden in your test suite is going to hurt you. Now, the last two I've put in parentheses because for me, they apply to some sets of tests more than others. So if you recall the testing pyramid that I just showed you, I believe that these apply more as you go down towards the base of the pyramid. So granularity is around how little behavior can my test exercise. So if you're talking about unit tests right at the bottom of the pyramid, the granularity of a test should be a single behavior. So not necessarily a single assert statement, but a single behavior of that component that you're testing. Whereas as you move up the pyramid, you may have to run through quite a lot of behaviors to get anything useful. And at that point, granularity becomes hard to define. I still think we should always, in all of our tests, be looking for a single behavior being asserted for, being verified. And then finally, fast. This is absolutely essential at the unit test level, because your unit tests, you want your developers to run them on the desktop before they do a check-in. You want to get feedback from your CI server almost instantaneously. If your unit test run takes 10, 15 minutes, people are going to run it less and less. If your unit test will run in 10 seconds, they'll be able to run them all the time. So these are just this is my take on what makes for a good, what properties, what qualities we should be looking for on our tests. I'm not completely on my own here. A lady called Roy Osherove was talking about it in his first book, and he talked about maintainable, trustworthy, and reliable. Emily Bache went on and did her own take. She came up with coverage, readability, robustness, and speed. So Roy had 3 qualities. Emily had 4 qualities. As you see, I've got 6 qualities, so this is clearly better. Unfortunately, Roy Osherove, in his second book, has now expanded his to 9 qualities, so I've got some catching up to do. Now, it's worth... So there's a lot of text here, and I don't generally like putting text on slides, but this is from a session by Ian Cooper. And Ian Cooper has got some interesting things to say about what you should test and at what level. And he's got... I don't necessarily agree with everything that he says, but this is an extremely important point here. So if your tests know too much, it's going to be difficult to maintain them. It's going to be difficult to change your system. And this is at the heart of making sure that your test suite remains maintainable. Because once they know too much, that means that they become over-specified. It means that you can change things that aren't relevant to them, and they'll still break. And this is where your test suite becomes a real burden to development and evolution of your test suite, of your application. So here we go, the bottom. Instead of assisting change, our tests have now begun to hamper it. And that's the thing that we're going to try and avoid. So a thought experiment from, I'm sure most of you know Robert Martin, Uncle Bob. Which would you rather lose? If I gave you the choice today and asked you, would you prefer to lose your production code or your test suite, which would you choose? It's a real question. You, sir, which would you lose? So for those of you that didn't hear, the gentleman was very honest. He said that he thinks what it should be is that you should be able to lose your production code and keep your test code, because the underlying assumption is that test code fully specifies what your production code should do, and therefore with a full set of executable specifications, you should be able to relatively easily evolve or rebuild your production application. Whereas if you lose your test code, and you keep your production code, well, the system's still working today as it was working yesterday. But if you need to change it, you find a bug that needs to be fixed, you no longer have the test coverage to make sure that you have got good documentation of how the system works. You no longer are sure that you haven't broken something else somewhere else in the system. And he ended up by being very honest and saying that despite the fact that he thinks that you ought to be able to choose to keep the test suite, in reality, most of us would have to choose to keep the production code. Now, clearly, this is just a thought experiment. You're probably going to lose both of them or none of them. So it's not something that I encourage anybody to do, but it's worth thinking about as you look at your test suite. Is the test suite sufficient to allow me or enable me to re-implement my production code should I need to? And I guess there's an element of risk here. What is the risks that we're trying to address when we write tests? There's a risk that we need to mitigate. There are problems that occur in the field that can destroy our software, they can destroy our customers' data, they can cause bad reputations and outcomes for our company. So let's talk a bit about risk. Now this for me is the core book on managing risk in software projects. It's by DeMarco and Lister, another couple of well-known consultants, and it has a few good quotes in it. And one right in the introduction, right up front, and actually, if I remember rightly, in bold, says, if there's no risk on your next software project, don't do it. Now, there's something important to understand here, because risk often comes with a bad feeling. We shouldn't take risks. We hear managers talking about, how can I get rid of this risk? Whereas we all know that everything that we do every day has an element of risk in it. Risk is it's inherent in our lives, and risk is inherent in any software project. Because if there's no risk, then it probably means it's been done before, or your customers can already do it. So we are taking on risk. What we need to do is understand what that risk is and manage it. And one of the ways we manage the risk in a software project is by writing tests that can assure us that it does what we think it ought to do, that it does what our customers want it to do. Now, here's a lovely diagram from a colleague and friend of mine, Dan North, and he went through a phase where he did his slide decks by drawing them out on index cards and then taking photographs of them. So I rather like the format of this diagram. But anyway, let's look at the axes. So down here we have the likelihood of a defect slipping into a component within the software. And going up the y-axis, we have the impact on the business and on the customers of a defect escaping, being experienced by our customers. So for instance, this component up here, there's a high likelihood that there'll be a defect in it. So for instance, it's maybe a new piece of technology, or it's over a network, or it's highly complex. But it's also got high impact. So that if it goes wrong, we might lose a lot of money, or our customers might be very unhappy. So for instance, call to mind I can't even remember which trading company it was, but they put a little bit of trading software live a couple of years ago. They had a minus sign where they didn't expect one. It kept selling and buying stocks at one price and then selling the stocks for less money. And they lost, I think, 600 million in 20 minutes or something like that. That was high risk and high impact. Down here, this is low likelihood and low impact. So let's think about what that might mean. Maybe it's the color of a button on some GUI that you've developed. Is it important that that it could be the wrong color? How likely is it that you would set it to be the wrong color? And if it was the wrong color, how dangerous would it be? So we're going to have a whole range of pieces of our system that are more or less complicated and have more or less impact when they go wrong. And they're all connected together, and you want to test some of them. You at least want to mitigate the risks of releasing this out to your customers. So one of the main tools, in fact possibly the only tool that is in regular usage in software development teams at the moment, is coverage. So could I get a show of hands? Who uses coverage statistics in their work? Yeah, quite a few. So this one here, low impact, low risk. Is 80% coverage too much? This one up here, is 80% coverage enough? So it's not about trying to apply the same heuristics to all of your software. It's about looking at the software and making risk-weighted judgments about what sort of testing is needed. There's a deeper question underlying these 80% numbers about what exactly does coverage buy us? So has anyone got some doubts about the usefulness of coverage? So some people have put their hands up. Yes? Yep. So that's essentially it. Coverage, and so this is not a session on coverage as such, but coverage is a statistic, it's a number that tells you very little. it tells you what code has definitely not been tested. It doesn't tell you anything about the quality of the tests that you've already written. And therefore, if anyone has got that feeling that maybe applying a ratchet metric such as coverage to your builds so that the coverage always goes up, I'd suggest that's a really bad idea, because there's a law of unintended consequences, and it will lead to people writing tests just to ensure that the coverage number goes up, but those tests themselves might be appalling. So I'd like to just briefly introduce you to this concept, or this technique known as mutation testing, which has been around certainly in academic institutions for 40 odd years. And this is about fault injection, automated analysis of your code, which mutates the code and injects a fault, and then runs your test suite over that mutated piece of code. And if none of the tests fail, then it's at least told you that that defect that has just been injected isn't caught by your test suite, and therefore gives you early warning that your test suite is possibly not as good as you would like it to be. This is a slide with PyTest, which is a Java-based mutation testing framework, which is state-of-the-art and really good. How many people here work in Java? Okay, that's more than I got last time I gave this talk. So I strongly recommend anyone working in Java take a look at this this tool, because it's extremely good and it has some very useful optimizations to make it run in finite time. Any of you working in .NET and C# and things like that? So the news for you, I'm afraid, is less good. There are a number of .NET mutation testing libraries out there at the moment. Most of them are not under active development, and all of them suck. So Java boys, have a go. Anyone working in .NET, then I would encourage you to collaborate with the people that are currently are developing mutation testing libraries and try and help them, because it would be a really good thing to have in the .NET world as well. So we're talking about risk, and I'm sort of leading up to talking about test-driven development. But this here is the picture of a book by Kent Beck. So Kent Beck is the father of XP, probably the father, certainly, of the terminology of test-driven development, and that's the book that started it all. And this quote doesn't actually come from the book. It comes from a Stack Overflow question, I think from 4 or 5 years ago. And it's a really important thing here, which is that Kent himself is saying out here very clearly he is not paid to write tests. So it is not our job to write tests at any level of the stack. What it is to get value to the customer. However, he goes on to say that he writes enough tests to get to a level of confidence. That is, he wants to write enough tests to mitigate the risks of releasing the software out to the real world. And he goes on to say that he believes that his level of confidence is much higher than the industry average. That is, he'll write more tests than most people. And that is possibly why a lot of people have come to the maybe mistaken conclusion that Kent Beck would tell you, you must always write tests, or there are never too many tests. That's definitely not what he believes, and that's definitely not what I believe. So we're trying to mitigate the risks, and this is how we go about doing it. So, I'd like another piece of audience participation. I haven't been very good so far at getting you to participate, but let's have a shot. When do you write tests? So those of you that write, for instance, unit tests, when do you write them? Okay, let's try it again. Who writes unit tests? Okay, you, sir, when do you write them? Before the code. Anybody else? When you change something. Does anyone not write unit tests? After writing the interface? Without tests, okay. When you discover a bug? After writing the code. So, thank you. So, some of the time it's never, which the gentleman referenced legacy code. After writing the tests is fairly common. So if you ever, I guess most of you are working in an agile way, given this is an AgileByExample conference. So has anyone ever said to you, I'll write the tests in the next sprint? I've heard that. Quite often you might iterate and write tests as you go. But the specific one that I want to look at is before writing the test. Sometimes it's test-driven, sometimes it's just test in advance. It's not actually driving the code. But before we move on to that, I'd like to remind us of the definition of what legacy code is. So the main thing that distinguishes legacy code from non-legacy code is tests, or rather a lack of tests. So that comes from Michael Feather's book. And what this is telling us is that legacy code is not about how old the code base is. It's not about what framework it's written in. It's not about what technology you're using. It's about whether it has tests. So you can write code today, and as soon as you press the commit button, it's already legacy code. What we're talking about here is trying to write tests to ensure that it doesn't become legacy code, that it remains maintainable, and you remain agile and responsive to change. Everybody in this room, whether you think you do or not, has legacy code that needs to be maintained. And given that you have legacy code that needs to be maintained, you should do yourself a favor and make sure that you have a copy of this book somewhere in your organization. Because although it's quite dated, it covers a lot of the approaches that even with today's languages will help you take legacy code and put it under test. So TDD, this is your standard red-green cycle that has been popularized since Kent Beck started writing his book. So the idea behind test-driven development is you start by writing a failing test. So here what you're doing is you're thinking of a single behavior that you would like your code to exhibit, a single example of how it would exhibit that, and then you write a test to validate that it doesn't already do that. So you write the test, you run the test, and at that point the test should fail because you haven't written the code yet. So that's the red phase. You then make the test pass. So there's a lot that we can talk about here. Quite often what you want to do is make the test pass as quickly as possible. So that doesn't necessarily mean, and quite often means, that you should not try and implement it in the final production way. You want to get the test passing. Maybe you will just return a null. Maybe you will just return a constant value. You want to get the test passing as soon as possible. This is sometimes called not just green, but shameless green. You want to get it green. No shame at all about silly switch statements. As long as you then remember the third part of this cycle, which is refactor. So you look at your code and you ask yourself, am I shameful about this code? Is this the code that I would want to receive from another developer? And if the answer is no, then you refactor. And you may go around this refactoring loop many times until you get the design, you get the structure of the code that you want. But the thing about writing the test first means that at each phase of this refactor, you can run the tests again, and they should still be green. In fact, if you've broken something, one of them will go red and tell you that you've mucked up. So this cycle, it means that you write tests before you write code. It means that you see the test fail, which means that you, to some extent, are debugging the test before you actually implement the code. You make the test pass as quickly as possible so that you're now in a point where you can refactor as heavily as you like while keeping the tests green. And you iterate very rapidly in that way. So if you're doing this at the unit test level, then clearly this cycle you can repeat every few seconds. So many of you will, the people who put up their hands working .NET, there are tools like NCrunch that will run the unit tests as you type. And that's what we're trying to achieve. We're trying to get fast feedback. By writing this first, we are explicitly saying how we are going to use this code. So we are designing our interactions with it. We're designing the interface. And that's really important because if you find writing this test is hard, that's feedback. That's telling you that there's something difficult about writing and using, writing code that will use that component. And so you should always listen to your tests. So this is a picture of yet another book. So this is a Growing Object-Oriented Software Guided by Tests. This, for me, was possibly one of the most important books that came out in the first decade of the 21st century, because it's so much more than just TDD. It's talking about a whole philosophy of design. The examples are written in Java, but that shouldn't let anyone not working in Java, shouldn't let you get put off, because it's a truly essential book for software development. So it is for developers. It's not a high-level book, but it's around the philosophy of how components should communicate, what it is to design a system that is flexible and open to change. So listening to your tests, they didn't coin this phrase. This is a phrase that's been around since the early days of writing tests, but what they did was exemplify it and demonstrate through their worked example how you should respond. So essentially what we're trying to do is make sure that if the tests are easy to read, easy to write, and if they're not, then don't just go, this is hard to test, I'm not going to test it, or this is hard to test, I'm going to have a 200-line setup. Think about what in your design has caused your tests to be difficult to write, caused your code to be difficult to test, because that's the important feedback that they're giving you. So I guess you can tell that I'm quite keen on test-driven development, that I think that it's a good way to go, that it gives us large amounts of value. And a few years ago, I ran a survey online trying to work out, given that it seems to me to be such a useful practice, why were so few teams using it? And so my survey, I learned something. You should learn something from everything. And so the main thing I learned actually from the survey was never run a survey with a free text box in it. Because people will type things into the free text box, and then you have to read them all and try and work out what their meaning was. So having plowed through 400 free text boxes, I was able to divide it into these 5 different areas. So much easier to just put those 5 different areas there to start with. And as you can see, the split was pretty even. So a lot of people said, I don't know how to do TDD. It seems really hard. No one can teach me. There was another sector that said, we just don't have the time. There's another segment that said, I'm not convinced that there's any value to doing unit tests or certainly practicing TDD. Other people said, my project isn't the right sort of shape for TDD. And there was a bundle of people said, my organization won't let me do TDD. It would be culturally unacceptable. Now, all of these reasons can be refuted or at least challenged. But it's true that any new practice takes time and it takes effort. And it's also true that the software development world is divided on the value of test-driven development. To some extent, it's also divided on the value of unit tests. To some extent, it's also divided on the value of tests. So I saw a somewhat humorous, I believe, blog post about a new methodology, which is called stack trace-driven development, which is where you release the software and you wait for the errors to come back from your customers. So I think the only thing that was humorous about it was they said it was new. It's been going on for a while. So, some faces, some of which you might recognize, some of which you might not. But what have they got in common? So the first thing is that they're all white males. So this is a diversity comment. There are so few females working in this field, or at least so few females who have been expressing a view on this. And in fact, looking around this audience, I also see very few women in this audience. So we do have a diversity issue, but that's a side statement, an aside. These guys have all written about tests, unit tests, test-driven development. Most of them are pretty much in favor. DHH sparked off a huge internet communication blog war, what you would like, earlier this year after his RailsConf speech where he said that TDD damaged design. Jim Kaplan is a famously contrary character. Sorry? okay, Loon. Now, I'm sure is that non-violent? Anyway, so he's a famously contrary character, and he's had some very strong words about unit testing and integration testing. Jim Shaw has written about integration tests are sham. Basically, there's a wide number of people here. Dan North has been talking in the past, or quite recently, about how he thinks that you can accelerate Agile by dropping the testing if you have quick feedback and a really excellent team. So there's a number of different views being expressed. All of them actually think that testing is a good idea, but they have different ideas about how much of your application stack, what sort of tests you should write and when. So this led to the question of whether you should do TDD or not. But that is not the question. The question is not whether you should TDD, whether TDD is good or TDD is bad. It's whether TDD is appropriate for the way you work, it's appropriate for your organization. And what I've found is that these gurus or consultants or however you'd like to call them, they speak to an imaginary person. They're speaking to somebody at a skill level that they have assumed. And that's maybe not necessarily to you. Or I guess if you look at it from another perspective, when you read an article, how do you know if that article is directed at you where you are now? Or is it directed to somebody else who's at a different level of experience or a different level, working in different technology or in a different context? So this is a contextual thing, and I think a lot of the disagreements and discussions that were going on around the TDD is dead debate that you can follow on Twitter, or you can go and have a look at the discussions that were recorded between Martin Fowler, Kent Beck, and DHH earlier in the year. A lot of that is founded on the basis of, well, we're just talking to different constituencies of people. If you want to sort of a leg up, rather than trying to troll through the whole internet to track this debate, I posted a list of, I thought, the salient posts on my blog site a few months ago. I think really what we're here is we're at a level of, we're trying to work out who you are, how experienced you are, and trying to make sure that the information, the advice that we are taking on board is suitable for our level of practice. And so I want to either introduce or remind you of the Shuhari principle that underlies a lot of martial arts teaching. So who's seen Karate Kid? A few, okay. So Karate Kid, you may remember that at one point when the kid starts learning karate, his master or his teacher tells him to put wax on the car and then take the wax off the car. So and he gets really upset because it's wax on, wax off. And the master says, until you can get the wax on and the wax off well enough, then you're not ready to move on to the next step. And this was an example, a popularized example of the Shuhari progression. And Shu is where the kid was at the beginning, where he has to follow the rule. At this level, this is probably the level Uncle Bob is generally speaking to. Bob is speaking to people who are trying to learn how to develop software. They're at their early stages of their career. They're maybe not too experienced. They should just do what they're told. And so what Bob says is, you must TDD, always, no question. And then after a while, you get to the where you break the rule, where maybe you look at that impact, likelihood, risk graph, and you go, this component, it's hard to test, and it's also got a low likelihood of breaking and a low impact if it does. So maybe I can do less testing here and get something in front of the customer faster to get feedback. And then, as you progress, maybe you get to be a true expert, where you can be the rule. And I think this is where Dan North is talking to, where he's saying to really high-performing, hugely experienced Agile teams, if you've got continuous build and continuous deployment and you've got metrics that give you immediate information about whether something's broken and auto rollback, maybe you don't need TDD. Maybe you're getting that feedback in other ways. So there's a progression. And I think part of the argument around TDD is about not knowing who the advice is being directed to, and whether that is us. Now we have another problem, unfortunately, in this progression, and it's it's to do with a sociological concern called the Dunning-Kruger effect, which is that if you ask somebody how good they are at a particular thing, the people who are not very good at it often overestimate how good they are, and the people who are really experts often underestimate how good they are. So, for an apocryphal story, Bjarne Stroustrup, maybe some of you have heard of him, he was the inventor and creator of the language known as C++, which is not famous for being easy to use. And when he was asked, not that many years ago, how he would rate himself on C++ on a scale of 0 to 10, he said 7. It's the creator of C++. Now, obviously, it's moved on since he created it, but it's still 7. Whereas I used to interview C++ developers for a company that I used to work for, and they regularly rated themselves 8 or 9. And that's just an example of the Dunning-Kruger effect in action. It's really difficult to know what you don't know if you don't know it. And it's very easy to see holes in your knowledge if you think you know, when you have a good broad overview of it. So it makes it difficult for you to know where you are on this scale. And so my advice to most people is to be a little bit humble and assume that you're ignorant. So take on board advice, but make sure that you think about, am I really as good at this as I think I am? Because I know that I'm often not as good at things as I think I am, and I'm fairly sure that a lot of you will have the same overconfidence that I do. There's also, so in the same way that I talked about the qualities of good unit tests, where I had more of them and so it was better, we in the West then, now what were they called? The Dreyfus brothers went off and did some research, airline pilots and so on, back in the 50s and 60s, and they came up with a model that has 5 levels in it rather than the Shuhari 3. But essentially the Dreyfus model of skills acquisition maps onto this Shuhari quite nicely. So how do we move up here? So we could read books, or we could practice. And I would suggest that the only way to get good at software development is to develop software. And the only way to get good at test-driven development is to try driving your development through tests. And if you're working in a place where one of the objections that we talked about earlier, such as your manager won't let you or you haven't got enough time, if those are things that are problems for you to do practice at work, then you may want to find another way of doing practice. So I'd like to introduce you to Cyber Dojo, which is an online, free, web-hosted development environment, which provides 30 or so different languages, where you and colleagues can collaborate and work in dojos in pairs to solve simple katas. So it has 30 or 40 katas built into it, but you can use any kata you like. And this is a very, very nice utility developed by a friend of mine called John Jagger. As I say, it's completely free. The value of it only comes when you do it in large groups, because you can then compare how different pairs in the group have been working. You can look at every change that people made. You can compare how long people are at green, how many times there were defects, and basically use it as the basis for a training, self-improvement workshop. So, the benefits of good tests. They check that the code works. So this is, foundational. They make sure that the code still works. So if you go and make a change over here in piece of functionality B, you need to make sure that you haven't broken something in functionality A. How many times have you had a defect? And you're going, but I only changed something over here. It shouldn't have affected that over here. Regularly happens. They are living documentation. So if you have a good suite of well-written tests, whether they are unit tests or integration tests or acceptance tests, they will document the behavior of the system at some level, and you will then be able to use them to give to new people on the team, to give to new product owners, to have a look and make sure that they understand how the system works. And the really neat thing about doing this in code, as in either using some BDD type tool like JBehave or Cucumber, or doing it in some unit level testing framework like NUnit or MSTest or JUnit, is that when your system changes, the tests will break, your build will go red, and you will then be able to make a decision. which is, have I introduced a regression, or is my documentation, i.e. the tests, now out of date? And you can make a choice. I'm either going to go and change the tests to make them work, or I'm going to go and change the code to take that defect out. Ooh, that's not what was supposed to happen. And then you also get design feedback, which is, this is listening to your tests. You're writing the test. If the test is hard, then there's something a little bit smelly about your design. And you can go in and change that. So, to sum up, any advice, and this is not in any way, is not limited to just TDD. Any advice you get from anywhere will be directed to an imaginary person, and that imaginary person may not be you. So you need to understand your context to understand whether the advice is applicable to you. But understanding your advice is hard. Understanding your context is hard. So you should really only make decisions based upon deep experience. It's very difficult for somebody who has not gone through a Shuhari experience of TDD to say TDD is rubbish. Just you're at a point where you don't know how things work. So consider learning to ride a bicycle. Did you fall off a bicycle the first time you tried to ride one? Yeah. Did you say, this bicycle doesn't work? Yeah, well, did it work or was it broken? No. So we have to keep practicing. You don't know that something doesn't work until you've tried it enough to get good at it to understand it. And then finally, this is just your bottom line, which is that tests, you need to have tests that make it easier to work with your code, to work with your system. If the tests are making your life harder, then you're doing something wrong. The tests are there to help you. Don't panic. Carry on doing what you're doing. You're all in work. These things, nothing happens overnight. If any of the things that I was talking about, if you think they apply to you, if you think you can take on board practicing TDD, seeing whether it fits in with your development process, just try it. If it feels hard at first, that's like riding the bicycle the first time. It will be hard. As you do things, you get better at them. The things that you found really, really hard yesterday, you will forget that they were even caused you a problem in a week's time. That's the nature of learning things. So, thank you very much for your attention.